next module, we will have a look to different composting technologies which are commonly used in low and middle income countries. These are windrow composting, passively aerated windrows, forced aerated windrows, in-vessel composting, and bin composting. Let's start with windrow composting. Windrow is the general term for an elongated pile of stacked raw materials. This method is suited to treat large volumes of biowaste and produce large volumes of compost. Aeration of the material is crucial. Oxygen needs to be replenished as it is consumed, otherwise the piles go anaerobic in the center, following a different decomposition process and producing foul odors. Making sure that the material is porous enough for air to pass through is always advisable. This is achieved by mixing fine, dusty, wet or soft materials together with structure-giving materials such as small branches, cardboard, or hard vegetables. In any case, the piles are normally turned, which can be done mechanically or manually. This way, the porosity is reestablished and air and therefore oxygen get into the pile. Besides, the materials which are at the exterior of the pile are now in the interior so that they can be decomposed by microorganisms. This technology requires low initial investment and maintenance. However, it needs a lot of space because the windows have sloped sides and cannot be put too close together. It ranks medium when it comes to the time needed for the composting process, and it is labor intensive. The second technology is passively aerated windrows. This technology consists of perforated pipes located within the biowaste pile which promote convective airflow throughout the material. The pipes can be located in different dispositions as shown in the pictures. The air that gets into the pile brings the required oxygen by the microorganisms. These piles are normally not turned during the process. Therefore, it is important to premix the feedstock thoroughly before placing it on the perforated pipes. It is advisable to insulate these piles with finished compost to ensure thermophilic temperatures reach the outer layers of the pile as well. This technology requires slightly higher initial investment and maintenance than non-aerated windrows as it involves a passive aeration system. It has similar space requirements. The composting process might take as long or slightly shorter than with non-aerated windrows, and it also requires less labor as the piles do not need to be turned. The next technology is called forced aerated windrows. They might look very similar to the previous ones. The difference is that blowers are installed at the end of perforated pipes or air ducts. These blowers inject air into the piles, preferably during the active phase, when the compost reaches high temperatures. Airflow can be adjusted by changing the frequency and duration of the blower. These piles do not need to be turned, and as in the previous ones, insulation with finished compost ensures that thermophilic temperatures are reached in the outer layers. This technology requires even higher initial investment given the need for a blower and aeration channels. Maintenance is also higher than the previous two. It has similar or slightly less space requirements since the composting process is even shorter and it requires less labor as the piles do not need to be turned. Our fourth technology is called in-vessel composting. This describes a group of methods that confine the composting materials within a container or vessel. Installations vary from very high-tech options where parameters are monitored, acting more as a bioreactor, to very low-tech alternatives. In all configurations, airflow and temperature can be easier controlled than with other composting techniques. Turning or steering takes place manually or mechanically as seen in the video. This technology is more capital intensive and requires more maintenance than the ones seen before. It requires less surface area than with the previous technologies since the composting process is shorter. Besides, little labor is required as the material is mixed within the vessel. And finally, our last technology is called bin composting. This technique is practiced mainly at household level, which will then treat little amounts of waste and produce compost for self-consumption. Biowaste is located in a container which most of the times has some sort of perforated wall for air to get through. Some containers include a steering mechanism as the one shown on the right. Bin composters can also be used in big scale, as in this installation where we see passively aerated big-scale bin composting examples. In this case, the installations are run by operators, and most of the times the produced compost is commercialized. Biowaste is most of the times inserted from above and removed from the bottom. The material degrades and compacts slowly as it gets down into the bin. This technology requires medium investment costs and minor maintenance. In order to treat the same amount of waste, it will require less space than windrow composters, as the waste is piled up vertically in the bins, without any sloped sides. Besides, no turning is required, and therefore labor is low, but the composting process might take longer than other options described before. This final table shows a comparative summary of the presented technologies, assuming they are all treating a similar amount of waste. However, keep in mind that in-vessel and especially bin composting can also or are normally be used in smaller amounts. In any case, the table allows to have a quick impression of which technology could suit your needs and constraints best. This is the end of the module. Now that we learned the basics on the science of composting and about the most common technologies used in developing countries, in the next module I will give you some more insights on practical aspects of composting, such as how to get a proper mix of different organic wastes or what environmental impacts composting as an activity can cause. Hope to see you there.
Continue